Hello all, myself Devendra Itole, Assistant Professor in ENTC Engineering Department from AISMS Institute of Information Technology, Pune. Today's topic is DAC interfacing with 8051. In this video, we are going to study the basics of DAC, pin diagram, and the program to generate a square wave and triangular waveform. DAC is a device that converts a digital code to an analog signal, either in current, voltage, or electric charge. Signals are easily stored and transmitted in digital form, but a DAC is needed for the signal to be recognized by human senses or other non-digital systems. There are two methods of creating a DAC: binary weighted and R2R ladder. The number of data bit inputs decides the resolution of the DAC, since the number of analog output levels is equal to 2 raised to power n, where n is the number of data bit inputs. Right side you can see the pin diagram of DAC 0808 dual in package. It is a 16 pin IC, starts from pin number 1 to 16. Pin number 1 is not connected, 2 is ground, 3 is VE, 4th is I output, from where we are getting the output of DAC. Pin number 5, 6, 7, 8, 9, 10, 11, 12 are the A1 to A7, A8, through which I have to give the digital input. 13 pin is VCC, 14 pin is V reference plus, V reference minus 15 pin, 16 pin is compensation. So digital inputs are converted to current, and by connecting resistor we can convert the result into the voltage. So the total current provided by IoT is function of the binary numbers at the D0 to D7 inputs of DAC 0808, and the reference current I reference is as follows: IoT equals to IRF D7 by T2 dash D6 by 4 till D0 by 256. Here is the pin diagram of DAC interfacing with 8051. We can see the I out is connected to the op amp, as the current of the I out of DAC is very low, so you have to amplify that one. And V reference plus and minus is connected to 5K through 5K. V reference plus is connected to plus VCC, V reference minus is connected to ground. And D0 to D7 of DAC is connected to port 1. To generate a square form generation, logic behind is that we have to make the port 1 at logic 1 for some period and for logic 0 for some period. So for that we have to apply that logic in the instruction. ORG000H, as port 1 is connected to DAC D0 to D7 through port 1, we have to give the input to the DAC. It means we have to make the port 1 as an output port. Move P1 comma hash 00H. Then move P1 comma hash 0FF. Initially I make as a logic 1. I maintain the logic 1 for some period by using the ACALL delay. Then move P1 comma hash 00H. I maintain the logic 0 for some period, ACALL delay, and then SJMP SQR. So like this way square wave generate continuously. A delay by using the move and DJ instruction, we are given some delay. Like this way square waveform generation by using the DAC. Triangular waveform generation by using DAC. First of all, you should know what is a triangular wave. Triangular waveform starts from initial point, it increments to some level, and at the same time it gets decrement. Because of that we are getting the angle. So that logic we have to apply here. Again ORG00H is the origin. Move P1 comma hash 00H. You have to make the port 1 as output. Initially we will consider accumulator 00H. We will move that A to the P port 1, then increment A. Now CJNE instruction in A, 1 is there, 1 is not equals to FF, so he has to jump to INCRR. So where INCR label is, again move P1 comma A. So it continuously loop will happen till A reaches FF. Once A equals to FF, it goes to the next instruction. He will not jump now, it goes to the next instruction. In next instruction move P1 comma A and decrement A. Now here we are not given delay. After FF directly we are decrementing, right? So decrement A, CGNE A comma hash 00H DECRR. A is now FF, FE, FE is not equals to 00, it has to jump to the DECR. So this loop continuously happen till A reaches 00H. Once it reaches 00H, we are written here SGMP up. It means the triangular waveform continuously we are getting on the CRO. Here delay subroutine is written, but it is not used into the triangular waveform generation. Now let us see as I will copy the square waveform into the Kiel software. So I copied that into the Kiel software. I have to check whether there is any error occurred or not. So I have to build it. First of all, remember you have to save, or if you are doing any changes there, translate, build, rebuild. So you can observe here 0 error 01 I am getting, and the X file is also created. If you don't have the hardware, then also I can check whether my program is correct or not. So for that, one feature is given in the Kiel software. First of all, I have to debug it. Click on OK. Now here we have to select a logic analyzer. Just click on this. Yes, here logic analyzer gets selected. Now click on the setup. It is already P2, but initially it is clear. You have to insert some new event.